morning to Ananda. Today we are going to see about the non-linear data structure. In the last video we see about the linear data structure. Today we are going to see about the non-linear data structure. In non-linear data structure is nothing but the data are not arranged in any linear manner. It should be arranged based on their free memory. That is the non-linear data structure. Whenever the free phase is available, the data are allocated to reduce the wastages of memory. That is the main theme of non-linear data structure. In this non-linear data structure, we are using the two main concepts. First one is tree. First one is a tree, and the second one is a graph. Today we are going to see about the trees and graph. First, we are going to see about the tree. What is tree? A tree is a collection of nodes. Okay. It is a collection of some finite n number of nodes. They are arranged in some sort of orders. For example, from the root, leaf, chain, like that order should be arranged in a manner. Okay. It is a finite collection of nodes. Is a tree. Okay. This is for example, this is a tree example. Here, this is a collection of nodes. Node is nothing but A is a node, B is a node, C is a node, and D, E, F, G, H are the nodes. Okay. The node at the top is called root. The node at the top is called, as always, it's called the root, and the nodes next to the root are called as chains. These are the chains of the nodes. Okay. In which some n number of terminologies we can able to define from that of tree. For example, what is a leaf? What is a root? What is root and what is a leaf? The node present at the top is called the root. So A is the root of the node. Okay. And what are the chains for the root node? P and C are the chains for A. So we can call this chain. So B and C are the chains of A. For example, like the D, E, F are the chains of B. D, E, F are the chains of B. Okay. So in which here the B is act as a root node and D, E, F are the chain. Okay. And next we are going to see about the siblings. What is siblings? What are the number of chain nodes represented the root node are called siblings. From a root node, n number of nodes available at the next level, then we are called as a sibling. For example, we will consider D as a node. So D, E, F are the siblings of B. For example, C, G is the siblings of C. Okay. For example, H is the siblings of G. Okay. H is the sibling of G. This is a siblings. And next one is a degree. Degree is nothing but the levels we can represent it in that of tree. Okay. For example, level 1 is considered as a degree 1, and level 2 is considered as a degree 2, and level 3 is considered as a degree 3. For example, the degree of A is, this is a 1, level of 1, this is the level of 2, and this is the level of 3. So for A we have a degree of 3. Okay, this is a degree. And next we are going to see about the level. From the root node we can able to consider the level. The root node is a level of 0. The next one will be the level of 1. And next we consider the level of 2, and this will be the level of 3. So in this tree we will have the level top as the level of 3. Okay. And next we are going to see about the path. What is a path? The path is a flow where we do. For example, A is a starting node and H is a ending node. So it will pass through the C and G. Okay, for example, A, C, G and H. This is the path where the node will get consideration in this. Okay. This is a tree. For example, this is a trees and then terminologies. Okay. In this tree representation, we have two types of. For there should be a difference between the tree and the binary tree. In tree, a node will consist of n number of nodes. A root parent consists of n number of childs, but in binary tree, a parent consists of only two childs. One is left child and a right child. If two childs only present for a single parent, then it is called as a binary tree. Okay, for example, this is an example for tree. For example, A, B, C, D, then E, and then F. For root node A, you will have a chain of B, C, D. This is considered as a tree. For example, binary tree. In binary tree, every node will consist of two nodes. Okay. For every parent will consist of two children. One is left child and right child. Then it is called as a binary tree. Okay. This is the left child and this is the right child. This left child and right child will be considered for the binary tree. Okay. This is the difference between tree and binary tree. Next we are going to see about the tree presentations. In tree representation, there should be two methods are used for representing tree. One is linked list representation. Another one is a binary tree adjacency matrix representation. Okay. One is linked list and other one is a adjacency matrix. This is a two way of representing the tree representation. For example, we consider a tree A, B, C. This is an example for tree in which we will represent it in the linked list like A. From that, we will consider as for B and for C. And for D, this is the linked list representation, how the tree can be represented. For in the adjacency matrix of adjacency matrix, we can able to show how the connections will be taken place from the top A, B, C, D and E. Okay. For example, adjacency matrix will be considered for A, from the A to B and then B to C. That is, for example, we consider taken for B, the connection will be shown from B to D and B to E and B to A. This is adjacency matrix. For C, the adjacency matrix is A. Okay, for example, for adjacency matrix, let us consider for A to B and B to C. For B, D, E and then A. For C, it will be connected only with A. Okay, for E, it should be connected with B. For D, it should be connected with B. This is the adjacency matrix, how the data should be connected, should be shown here. Next we are going to see about the tree traverse. It is one of the main concepts tree traverse and how we can visit all the nodes in the tree using this tree traverse. It is one of the main important questions will be asked in the university exams. Three traversal. In tree traversal, we have three types. One is pre-order, in-order, and post-order. Pre-order, and the second one is in-order, and third one is the post-order. Okay, these are the three types of tree traversals available. Okay, in which of pre-order, there should be some protocols and guidelines are followed. In pre-order, first we have to receive the left node, and then root node, and then right side. This is the collection. For example, this is root, left tail, root, and then right tail. This is a protocol. For in order, root, left, and then right. For post order, it should be left, right, and then root. This is the example how we can visit the tree in the tree traversals. For example, just consider an example for tree A, B, C, E, and E. In pre-order, how we will visit? Based on the left chain. What is the left chain? It is left chain B, and then D is the left chain. Okay, first will be the D, and other one is the root. What is it? D's root is B, right? It will visit B, and then right, and then E is the right, and then next we are going to see about the left. No left is present. Therefore, the root of A, and then C. This is for pre-order, and for in-order, we visit the first root. Therefore, A, and then left side we can go there. The first one is root B, and then the left is D, and then E, and then C. This is the order how we will visit in the in-order. For post-order, it will visit the left chain. For example, D, and then right E, and then left B, and then we can consider for right. Therefore, C last on the circle B. So it will visit in this order, and the main agenda is we have to visit all the nodes. Where how we can visit all the nodes in some kind of orders. Based on that order, it should be like the pre-order, in-order, and post-order. Based on that, it will visit all the nodes. This is one of the main advantages of the tree traversal. And next, we are going to see about the expression tree. Next, we are going to see about the binary search. In binary search tree, how the elements are stored based on the root values. There should be two conditions are available. First of all, you have to check the root node. Based on that, if the element is right, greater than the root node, it should be placed in the right side. If the element is less than the root node, it should be placed in the left hand side. This is the protocol for binary search. For example, we consider condition is you have to check the root value. Root value is nothing parent. The input value greater than root, place in right side. If input is greater than the root is greater than input, place in left hand side. This is a protocol where we can be able to show how the elements are to be placed. Okay, for example, let's consider some example. This is an input example for inserting the elements in the binary search tree. How the elements should be inserted. For example, let us consider the first node. Let us consider the first node is a 28. This we will consider as a root node. Okay. And the next element is 45. So 45 will be inserted. It should be compared with the root node. So 20 is less than the root node. So it should be automatically placed in the right hand side based on the condition number. And third one is 12. It should be compared with the root node. So it is less than. So it automatically placed in the left side. And next number is 64. It should be compared with the root node. It is greater than the root node. So automatically compared to the 45. 45 they compare with 65 is greater than. So it is automatically placed in the right hand side. And 43 compared to the root node, it is higher, so automatically come to the next 45. Compared to the 45, it is less than, so it will be automatically placed in the left hand side. And next one is a 10. It is compared to the 28, it is less than, so automatically come to left hand side. It will compare to the 12, it is less than, so automatically it will place in the left hand side. And next one will be that of 7. It should be compared to the 28, less than, so automatically left hand side. 12, it is less than, so automatically left hand side. 10, it is less than, so automatically placed in the left hand side. And next will be that of 4. So 20 compared to the 20 will be less than, so automatically come to the 12. And that of 10 and compared to the 7 will be less than, so it will automatically place in the how this is how the binary search tree is work and how the elements are placed in this order. It should be compared and we can able to define how the elements are placed and how the elements should be inserted based on the condition we can define in the binary search. Next we are going to see about next we are going to see about the shortest path first. Shortest path. There should be n number of algorithms are used for find out the shortest path. To find the minimum value, there should be extra algorithm. Prince algorithm. Muskel's algorithm. These are the various algorithms were used for find out the shortest path in the data set. So, for example, we just consider a graph E, P, let us consider this is the graph where we can able to find out how to find out the shortest path of the graph. For example, A is a node, starting node, and B is a ending node. We can able to define n number of paths here. For example, we can able to define to starting and then end. We can define by n number of algorithms like A, there is a various paths are A, B, C, D. This is one of the paths. And next one is A, E, B, C, D. And next one is of A, E, F, G, D. And next one of A, E, F, G, C, D. Like this, n number of paths are available. We have to define which path is the shortest path to obtain. For example, we just consider this path. That should be 12, 8 is 20, 20 plus 4 is 24. This path we are able to define 24 is a last. By using this path, We can define 3 plus 1, 4, 4 plus 4, 8, 8 plus 6, 14 is a class. We can define this part 3, 5, 6, 6 plus 6, 12. And we can define this part 3, 4, 4 plus 4, 8, 8 plus 6, 14. So it should be that of 14, but this part will be that of 12. So the shortest path we can able to define is A to E, E to B, B to G, and then G to D. This is the shortest path. So the total cost is 4, 8, 3, 2, 5, 6, 6 plus 6 is 12. This is the total cost. This is the lowest cost for destination. We have to find this kind of shortest path, how the problems, how we can able to define and how we can able to solve this and to find out the minimum cost to attain our destination. We should be using n number of real-time solutions also for using the Google map from source to destination to attain our target level, to find the shortest path. Like it should be to reduce the resources, to reduce the manpower. At that situations, you should be doing a wide route. Okay, this is the shortest path algorithm, how we can able to use it. Okay, next we are going to see about the graph traversal. What is graph? Graph is also a collection of nodes, but it does not have any priority order like tree. So graph should be connected, should be directed or indirected. We can define n types of graphs. It will be based on the graphical methods. Okay. In this graph traversal, we have two graphic traversal. What is birth first search, and second one is a depth first search. First one is a birth first search, and second one is a depth first search. Okay. For example, just consider the graph. For example, just consider this graph. Okay. Birth first search is based on that of levels. Okay. For example, we just consider this level 0, that of level 1, level 2, and this is of level 3. Based on that level only, it will be showing how it will reach. For example, in birth first search, A, and then B, and then C, and then D, and then E. Based on that level, it will visit all the nodes. Okay. In depth first search, based on the depth level. Okay. So in that depth first search, it will visit the nodes in the order of A, E, D, E, and then C. Like this only, depth first searches working on it, and it will visit how the nodes are to be visited, and it will be based on this. Okay, this is a graph traversal. This birth first search will use the mathematical of tree, and depth first search will use the mathematical of graph. Based on that, it will visiting the orders of the data should be represented. Okay, and next we are going to see about the sorting and searching. Searching is one of the important method how to find the data in the database and how to find the data in the memory. For that, we will use searching concept. In searching, in data structure, we have two types of search. One is linear search, and other one is a binary search. one is a linear search and the second one is a binary search. Okay, in linear search, it will compare elements in a one by one. For example, just consider first we have to do the array size. Array size is 5. Therefore, I just do the array of 0 is 10, array of 1 is 12, array of 2 is 15, array of 3 is 24, array of 4 is 46. This is the input I just given to find. I just do 24. The 24 is present in that database. Yes, right. It will compare with every array element one by one. Okay, for example, it will compare 10 equal to 24, not equal. So it will go to the next number. 12 to 24, not equal. 15, not equal. 24 equal to 24. So automatically the number we are searching should be find it out here. So this kind of type of search is a linear search. How the numbers compare to one by one numbers. That is a linear search. And second one set of binary search. In binary search, it will compare the database into two splits based on the lower level and the higher level, and compare it to find out the mid value. From that mid value, it will find out if the number is greater than that mid value, it should be in the second half, otherwise it should be in the first half. Okay. For example, array size is 6. Therefore, array of 0 is 10. Array of 1 is 20. Array of 2 is 30. Array of 3 is 40. Array of 4 is 50. Array of 5 is 60. Therefore, we have to add the binary search equal to low plus high divided by 2. So, array size of low value is 0, high value is 5 divided by 2. Therefore, we have get 2.5 will be accumulated to 3. So, based on that, we will split the database into two types. Okay, 20, 30, 40, 50, 60. Therefore, this is a good value. Okay. So, I have to find out whether the number to find is number is 50 means automatically we will find out that the number should be presented in the greater than the mid value. So it will easily find it out. It should be mid value, therefore 40 compared to the 40 it should be high. So next element is 50, 50 will be automatically find it out where the number is present. This kind of search is a binary search. Okay, this is the two types of search where we can able to use it. Okay. And next we are going to see about the sorting. Sorting is nothing but arranging the element in any type of orders. For example, it should be arranged in ascending order or descending order. There should be n number of sortings are available. Wedge sort, quick sort, heap sort, bubble sort. Like that, n number of sortings are available for arranging the element in any ascending order or descending orders. Its main concept is to arrange the element in any linear order. For example, just consider mainly we are using in our concepts of mid sort and quick sort. Today we are going to see about the wedge sort, how the elements are sorted and how we can able to define it. For example, In mesh art, we are using the concept of divide and conquer. Based on that, we can split the data and we can arrange the elements in the linear manner. Thank you.